Thank you everyone for joining me in my very first class. And today I'm going to treat the Earth, longitude and latitude. It's already on the board. The Earth is approximately a sphere of radius 6,400 kilometers and circumference 40,000 kilometers. The Earth is divided into two hemispheres by the equator. The equator divides the Earth into two hemispheres, one half to the north, another half to the south. And of course, you have the polar axis that runs from the North Pole through the center of the Earth to the South Pole. So we have something like this. You have the polar axis, which runs through the center of the Earth, where you have O in the center of the Earth, to the South Pole. The polar axis runs from the North Pole through the center of the Earth to the South Pole. Like I said earlier on, the equator divides the Earth into two hemispheres. One hemisphere to the north, the other one to the south. Now, with reference to the equator, of course, the equator is latitude 0 degree. You will come to understand all that later. With reference to the equator, we have what we call circles of latitude. Circles of latitude. We have them to the north and to the south. So we have something like this. These circles of latitudes are found north of the equator and south of the equator. You can see that the circles of latitude have their planes parallel to the plane of the equator. Suppose I call this one latitude 70 degrees north. I call this one latitude 30 degrees north. Suppose I call this one latitude 60 degrees south, and call this one latitude 80 degrees south. I have told you that these circles of latitudes have their planes parallel to the plane of the equator. What it means is that, and of course, their centers, the centers of these circles of latitude lie along the polar axis. You can have this, call it A. You can have this, call it B. You can have this, call it C. You can have this, call it D. This is the radius of this circle of latitude. This is the radius of that circle of latitude. Of course, this is the radius of the equator, which is the same as the radius of the Earth. As a matter of fact, any distance from the center of the Earth to any point on the surface of the Earth is equal to the radius of the Earth. These are the radii of the various circles of latitude. Now, take note that the equator is taken to be the latitude 0 degree. Now, with reference to the equator, these other circles of latitudes are measured. They are measured to the north or to the south, with the maximum being 90 degrees. As you can see, the equator is latitude 0 degree. As you move up, the angles will be increasing. 30 degrees, 70, and finally 90 at the polar axis. So that the maximum value of a circle of latitude is 90 degrees. If a point is on latitude 90 degrees north, it means that it is at the polar, at the North Pole. 90 degrees south means it is at the South Pole, and so on and so forth. Now, we have lines of longitude with the primary line of longitude known as the meridian. The meridian. Let us look at a line of longitude this way. Now, this is a line of longitude. If we take this as a meridian, the prime meridian, the prime meridian or the meridian is taken as longitude 0 degree. Now, with reference to the prime meridian, let's call it prime meridian. Prime meridian. With reference to the prime meridian, other lines of longitudes are measured west or east. With reference to the prime meridian, other lines of longitudes are measured west or east. It is very important to note that lines of longitudes run round the Earth through the north and south poles. We call them great circles. Why are they called great circles? They are great circles because they have the same radius as the Earth. Every line of longitude has the same radius as the Earth. You should also note that the equator is a great circle because it equally has the same radius as the Earth. Very different from circles of latitude, which you can see clearly. Each of them has its own radius. Now, like I said, with reference to the prime meridian, lines of longitudes are measured west or east. For example, this line of longitude is west of the prime meridian, whereas this one is east of the prime meridian. Now you will get a clear idea of these positions by looking at the points where the lines of longitude cut the equator. What I mean by that is, if you join this, join that, you join that. Suppose I call this point here P, I call this point Q, call this point R. I want you to see clearly that the point P is a point on this prime meridian and a point on the equator. In fact, the lines OQ, OP, OR, they are in the plane of the equator. They are in the plane of the equator. Now, angle POQ is west of the prime meridian. Angle POR is east of the prime meridian. You will get a clearer idea of what I'm saying by looking at something like this. Let us call this the equator. The center is over there. Now, the prime meridian cuts the equator at the point P. The line of longitude west cuts the equator at the point Q. The line of longitude east cuts the equator at the point R. So, as a matter of fact, this diagram represents the equator in this diagram. This diagram gives you a clearer idea of the plane of the equator in this diagram. You will get a clearer idea there. Now, like I said, the line of longitude west of the prime meridian has this angle QOP. The line of longitude east of the prime meridian gives you angle ROP. The diagram makes it clearer for you that way. What I'm now telling you is, if I now say that this is longitude, suppose I call this longitude 50 degrees east, and I call this one longitude 30 degrees west. These angles I am talking about here now can be shown clearly here as this angle being 50 degrees and this one being 30 degrees. It is a measure of this angle that gives names to the lines of longitude. When a line of longitude is 30 degrees west, when a line of longitude is 30 degrees west, it can be clearly seen in this diagram, the way it behaves. You can see it clearly. The longitude passing through Q is west of the prime meridian, and the one passing through R is east of the prime meridian. The diagram here shows you very clearly the measure of the angles which give names to these lines of longitude. So, in summary, circles of latitudes are measured north or south of the equator. Lines of longitudes are measured west or east of the prime meridian. circles of latitudes measured west or east of the prime meridian. But so I tried to explain the difference between circles of latitudes and lines of longitude. Circles of latitudes are measured north or south of the equator. Lines of longitudes are measured east or west of the prime meridian. Now, we are going to observe something. We are going to observe something, and what is it? Now, suppose I want to talk about the difference in longitudes. The difference in longitudes. What I mean by that is, suppose I want to know what is the difference between longitude 30 degrees west and longitude 50 degrees east. What is the difference? The difference is clearly shown on this diagram. We are looking for angle QOR, and angle QOR is angle QOP plus angle ROP. That is 30 plus 50. So the difference in longitude between longitude 30 degrees west and longitude 50 degrees east is 80 degrees. That is adding 30 to 50. It is very interesting to note that this difference is given by the sum of the two angles, because the two places are on opposite sides of the prime meridian. Now suppose we take another line of longitude, maybe take it to be east, further east. Suppose we call that one longitude longitude 80 degrees east. Longitude 80 degrees east. Assuming that it crosses the equator at a point S, called the point S. I can still show it on this diagram by putting something like this. You will take note that this longitude 80 degrees east is measured from here. That is the angle you are calling 80 degrees. What do you observe now? You observe that if you are looking for the difference in longitude between the longitude passing through R, that is longitude 50 degrees east, and the longitude passing through S, which is longitude 80 degrees east, you see the two of them are east of the prime meridian. You can now see that if you are looking for the difference in longitude between longitude passing through R and one passing through S, it is going to be this angle here. And that angle there is what? Angle POS minus angle POR. That is 80 minus 50, 30. What do you observe? What you observe now is when two places are on longitudes on opposite sides of the prime meridian, the difference in longitude is the sum of the angles. But if they are on the same side of the prime meridian, the difference in longitude is the difference in the two angles. You subtract the smaller one from the bigger one. So take note how you obtain the difference in longitude between places. Are the places on opposite sides of the prime meridian? Are they on the same side of the prime meridian? When they are on opposite sides of the prime meridian, you add the angles to get the difference. When they are on the same side of the prime meridian, you subtract the smaller one from the bigger one in order to get the difference in longitude. This is very important. I do believe that you have understood how we can obtain differences in longitude between places on the Earth's surface. I think I may have to take a kind of worked example. Let us take some examples. If you watch carefully what I have drawn there, let me assume that this is the prime meridian. The prime meridian is taken to be longitude 0 degree. Longitude 0 degree. Now, with reference to the prime meridian, I have drawn several lines of longitudes cutting the equator at places I will now call, I will call this one A, I will call this one B, I will call this one P for the prime meridian, I will call this one C, I will call this one D, and this one E. What I have shown you is, I have shown you lines of longitudes and the prime meridian, all cutting the equator. Don't forget, the equator is latitude 0 degree. What the equator is to circles of latitude is what the prime meridian is to lines of longitude. Now, take note of this. If I now give names to these lines of longitude, suppose I call this something, call this something, call this something, and call this something. What I mean by that is, suppose I now say that this is longitude 50 degrees west, and this is longitude 30 degrees west. And this one is longitude 20 degrees east, longitude 20 degrees east, This one is longitude longitude 40 degrees, 20 degrees east, 40 degrees east, and 60 degrees east. Now, take your time and see what I'm trying to illustrate here. This is longitude 50 degrees west because it is west of the prime meridian. You can see the prime meridian. It is west of it. The other one is longitude 30 degrees west. That is the one passing through A is on longitude 50 degrees west. The one passing through B is on longitude 30 degrees west. The one passing through C is on longitude 20 degrees east, because it is now east of the prime meridian. The one passing through D is on longitude 40 degrees east. The one passing through E is on longitude 60 degrees east. Now, take note. These angles we are referring to can easily be determined if we take O as the center of this circle. That is the center of the earth. From there, take a line to A, take a line to B, take a line to P, take a line to C, take a line to D, take a line to E. You can see the array of angles there. You may find it difficult to actually understand how these angles behave, but let me draw another diagram and will make it clearer for you to understand what I have done there. So I draw something like this. What I have drawn here is what? The equator. This is the center of the earth. Now this is a line from the equator to the point P on the prime meridian. This is to the west. This again is to the west. This is to the east. This is to the east. This is to the east. So here is our A. Here is our B. Here is our C. Here is our D. Here is our E. It is easy for you now to see the array of angles the way they should be, because the name of the longitude passing through A is given by the angle AOP. The name of the longitude passing through B is given by the angle BOP. Similarly, the name of the longitude passing through C is given by the angle COP, DOP, EOP. That's how these longitudes have their names. And as it is now, we can now do a very simple exercise. Let us calculate the differences in longitude between these points. Let us do it as a kind of exercise. From the diagram, calculate the difference in longitude. Calculate the difference in longitude between let us say between A and B to C and D, three D and E, four A and C. A and C, 5. A and D, A and D, 6. A and E, A and E, 7. B and C, B and C, 8. B and D, B and D, 9. B and E, B and E, and 10. P and E, P and E, P and E. Now, we can easily work out these angles. Now, make sure that you observe how the angles are related. This angle is the angle they are calling the 50 degrees west. This angle is 50 degrees. This angle is 30 degrees. Now this angle is 20 degrees. This angle is 40 degrees. Whereas this angle, take note, this angle is the one that is 60 degrees. Now, we can now begin to calculate these differences in longitude by looking at this diagram. What is the difference in longitude between A and B? Look at A and B. A and B are on the same side of the prime meridian because P represents the prime meridian. A and B are on the same side. So from what we have explained already, the difference in longitude between A and B is 50 minus 30. Solution. One, difference in longitude between A and B is what? Is 50 degrees minus 30 degrees. That is 20 degrees. The difference in longitude between A and B is angle AOP minus angle BOP. That is angle AOP minus angle BOP. Angle AOP minus angle BOP. That is angle AOP minus angle BOP. Now, in the second one, we are looking for the difference in longitude between C and D. C and D. Of course, C and D are on the same side of the prime meridian. So we will repeat what we did here now. As long as they are on the same side, the difference in longitude is you subtract the smaller angle from the bigger angle. That is, in that case, A2 is P or DOP minus COP, which is equal to what? Which is equal to 40 degrees minus 20 degrees, and that is what? 20 degrees. Please take note that the difference in longitude between C and D is angle DOP minus angle COP. That is 40 minus 20. Now, number 3, D and E. D and E. Again, you observe that D and E are on the same side of the prime meridian, and so the difference in longitude will be smaller angle from the bigger angle because they are on the same side. So number 3 now will be angle EOP minus DOP, which is equal to what? 60 minus 40, which gives you again 20 degrees. I think I can now wipe off this diagram so that we can have space to complete the solutions. Now, number 4, you are looking for the difference between A and C. Now, very clearly, A and C are on opposite sides of the prime meridian. It will be angle AOC minus, plus angle AOP. You are looking for the difference in longitude between A and C. A and C are on opposite. So it will be angle AOP plus angle COP. AOP plus angle COP, which is equal to 50 degrees plus 20 degrees, which is 70 degrees. That is the difference in longitude between A and C. Take note that A and C are on opposite sides of the prime meridian. So the difference in longitude will be the sum of their longitudes, which is 50 plus 20. That's why it is 70. Now, between A and D, of course, it's going to be the same thing. As long as the places are on opposite sides of the prime meridian, you add the angles. When they are on the same side, you subtract one from the other. That is the rule. So, number 5 now. We are looking for the difference in longitude between A and D. It will be angle AOP and DOP. AOP plus DOP, which is AOP is 50, isn't it? 50 degrees plus 40. No, plus 20. Let's be sure that we are doing the correct thing. Angle AOP is 50, angle COP is, okay, the other one is DOP is 40. So this is 90 degrees. Now number 6. You are looking for the difference in longitude between A and E. A and E are on opposite sides of the prime meridian. So the difference will be AOP and EOP. AOP, EOP. AOP plus EOP, which is what? 50 degrees plus 60 degrees. What is it equal to? 110 degrees. 110 degrees. Now, number 7, B and C. Again, they are on opposite sides of the prime meridian. So it's now going to be BOP and COP. BOP plus COP. OP plus COP, which is 30 degrees plus 20 degrees. That is 50 degrees. BOP 30, COP 20. Now, difference between B and D. B and D. B and D again are on opposite sides of the prime meridian. B and C. B and C. B and C. They are on opposite sides of the prime meridian. So the difference in longitude will be the sum of BOP and COP. BOP, COP. Okay, we have answered 7. We are in 8. Okay, B and D. B and D. B and D will be BOP, DOP. BOP, DOP. That is 8. BOP plus DOP, which is 30 degrees plus 40 degrees. 70 degrees. DOP is 40. BOP 30. So the sum. And number 9 is B and E. B and E. Of course, they are still on opposite sides of the prime meridian. So that number 9 will be BOP plus EOP, which is equal to 30 degrees plus what? 60 degrees. The difference in longitude between B and E is given by angle, the sum of angle BOP and angle EOP, because B and E are on opposite sides of the prime meridian. That is 30 degrees plus 60 degrees, which is 90 degrees. Now the 10th question. The difference in longitude between P and E. You take note that P is a point on the prime meridian, and the prime meridian is longitude 0 degree. So the difference in longitude between the prime meridian and the longitude passing through E, which is 60 degrees, is 0 plus 60. 0 plus 60, if you like, is this is simply the longitude of E. The simply longitude E. The longitude, simply the longitude 60 degrees east. This is simply 60 degrees since the prime meridian, since the prime meridian is longitude 0 degree. So it is 60 degrees is the difference in longitude between P and E. Now we shall go over to circles of latitude. Circles of latitude. You will recall that I have already said that circles of latitudes are measured north of the equator and south of the equator. So Circles of latitudes are measured north of the equator and south of the equator. So assuming that we have something like this. Suppose this is latitude 80 degrees north, and this is latitude let's say 60 degrees north. And this is latitude 20 degrees south, and this is latitude 50 degrees south. These circles of latitudes have their planes parallel to the plane of the equator. And so, if we draw their diameters, have something like this, have something like that, have something like that, have something like that, have something like that. These diameters are also parallel. As long as their planes are parallel, they are also parallel. But they lie in parallel planes. Now, you can easily see that a measure of this latitude 60 degrees is when you take a line from there to the center of the earth. This is the angle you are calling 60 degrees. This one too. This is the angle you are calling 80 degrees. Similarly, this is the angle you are calling 20 degrees. And this is the angle, please take note, this is the angle you are calling 50 degrees. In fact, if I call this point P, call this point Q, call this point R, call this point S, then very clearly, angle QO, let me call this point here, E. E for the equator. Call that point E. So, if I say latitude 60 degrees north, the angle I'm referring to is angle QOE. 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 Angle QOE. QOE. This is angle POE. POE. And this is angle ROE. ROE. And this is angle SOE. SOE. These are the angles that give the names to the circles of latitude. So we can as well talk of difference in latitudes, just like we did. Difference in longitude. We can as well talk of difference in latitudes. Very clearly, you can see that if you are looking for the difference in latitude between Q and R, you will see that they are on opposite sides of the equator. They are on opposite sides of the equator. So the difference in latitude will be the sum of the angles QOE, ROE, which is what? 20 and 60. 20 and 60. But if you are looking for the difference in latitude between R and S, you can see that R and S are on the same side of the equator. They are on the same side of the equator. And so, if you are looking for the difference in latitude between R and S, it will now be angle SOE Look at it very carefully. SOE minus ROE. Because the difference is angle SOR. SOR. Angle SOR is given by SOE minus ROE. So you have to take note now that when you are looking for the difference in latitude, you carry out a similar exercise as you did for the difference in lines of longitude. When the places are on opposite sides of the equator, you add the angles. When they are on the same side of the equator, you find the difference between the two angles. So take note that let us find the difference in latitude between 1, P and Q, 2, R and X. There are and S. Let's take R and S. R and S. R and S. P and Q. R and S. Q and R. Q and R. Q and R. Now, let us very carefully observe this, because this is, I can draw a simpler diagram like this and take this to be our equator. Of course, this is the center O. This is the other one. This is the other one. This is our P. This is our Q. This is our R, this is our S. And so, very clearly, we know the angles we are talking about now. This is the angle we say is 20 degrees. 20 degrees. This is the one we say is what? 50 degrees. This is the one we say is 60 degrees, and this is the one we say is 80 degrees. So very clearly, let us take that as our solution. Yeah, we are looking for the difference in latitude between P and Q. P and Q. You can easily see that P and Q are on the same side of the equator. And so the difference will be angle POE minus QOE, which is equal to 80 degrees minus 60 degrees. What is it equal to? 20 degrees. 2, you are looking for the difference in latitude between R and S. R and S. R and S again are on the same side of the equator. And so you are looking for the difference between angle SOE minus ROE. R and S. R and S. SOE minus ROE minus ROE, which of course is equal to 50 degrees minus 20 degrees, which is 30 degrees. That is the difference. Yeah, now try to understand what I'm explaining here, that When the places are on opposites, now I'm going to number 3, where Q and R are on opposite sides of the equator. When they are on opposite sides of the equator, we now have to add the angles to get the difference. Number 3, we are looking for angle QOE plus angle ROE, which is equal to QOE is 60, ROE is 20. That is 60 degrees plus 20 degrees, which is equal to 80 degrees. A very important point to note here is that just like in the case of difference in angles for longitudes, where you consider places on opposite sides of the prime meridian and places on the same side of the prime meridian. So also in this case of circuit of latitudes, you consider places on opposite sides of the equator and on the same side of the equator. When the places are on opposite sides, you add the angles. When they are on the same side, you find the difference between the angles. You subtract the smaller one from the bigger one. And so we have rounded up our lesson on longitudes and latitudes. We have been able to establish how we obtain the differences in longitudes and differences in latitudes. In our next lesson, we are going to discuss how we calculate the radius of a circle of latitude and how we calculate distances between places on the surface of the earth. Goodbye and God bless.